Hi there and welcome to my channel. My name is Irfan and today I'm gonna go through Add Math Paper 2 from May-June session time zone 2 with you guys. So without any further ado, let's go ahead and start with question number 1. Question number 1. I'm given a cubic curve. As you can see here, it's already factorized. I have all the three linear factors and I have to draw it stating the intercepts with coordinate axis. So first thing first, since it's already in this form, it makes my life easier. All I have to do is to put each of these linear factors equal to 0 to find the roots of my curve, or in other words, the x-intercepts. So those are -3, 1, and 5 over 2 or 2.5 respectively. And I have to also find the y-intercept, and that can be done by putting the x equal to 0 in all these linear factors, and you end up with 0 minus 5, which is 5, 0 plus 3, which is 3, and 1 minus 0, which is 1. You multiply all together and you get -15, and that's the y-intercept. And lastly, you just have to connect them together. Just remember, if the leading coefficient of the cubic expression is greater than 0, so the curve would have a shape that looks like this. However, over here, the leading coefficient, which is the coefficient of x cubed term, all I have to do is just to take 2x and negative x, multiply them together. So if I were to expand this, I would get something like negative 2x cubed and the rest of the terms. So it's very clear that a is negative and my general shape should look something like this. And that's why I entered the page from the top left corner. I go all the way down, reach my minimum, pass through my y-intercept, go up, and just quickly turn around because I need to pass through 2.5 as well, and just from there you leave the page from the bottom right corner. And in part B, I have to solve this inequality. Basically, it's the same expression, but I'm looking for all the values of x which satisfy this inequality and makes it less than or equal to 0, and you can just find it from the graph. So that means anything below x-axis, which is this portion as well as this portion, since the 0 is included, so I should be careful and include those values as well. So x is greater than or equal to -3, less than or equal to 1, and all the excess, which is basically greater than or equal to 5 over 2. And in the last part, I have to sketch the same curve, but this time it is inside a modulus function. And what a modulus function or absolute value does is that it flips the curve about x-axis, and everything that is below the x-axis, basically you just flip it and mirror it about x-axis. But be careful that you should get sharp turns or sharp corners at these points. Some students, they make it a smooth curve, and that is wrong. And lastly, since the y-intercept of the original curve was -15, when you mirror it, you should get +15. And that's the final sketch. Question number 2. I'm given this definite integration and I have to evaluate it. So all I have to do is to take integration of cosine. However, I want to remind you, this is a composite function. So if you want to take the integration of cosine, you get sine x. However, the integration of cosine of ax plus b is the reciprocal of the coefficient of x, which is 1 over a times sine of the argument. So same thing over here. The integration is sine x over 4 times 1 over 1 over 4, which is 4. And then you apply the limits of integration one at a time. You substitute pi over 2 instead of x, which results in pi over 8 minus, and then the second time you substitute pi over 3, which is pi over 12. You just use your calculator to get this value and you round it to 3 significant figure, as I just did. In part B, I have to find the value of this indefinite integration. So what I prefer to do here is to rewrite the second fraction as a negative index. I bring the x up, it becomes -3. because it's easier to take integration. Now all I have to do is to add 1 to this power and divide by the new power, which is -2. That's where the negative goes. Also, for the first fraction, you can refer to the integration of 1 over x, which is ln x, but this time I have this linear expression with a constant. So therefore I have the ln of everything, except you need to divide by the coefficient of x, which is 4. Therefore I get 1 over 4 ln 4x minus 3. And lastly, do not forget the constant of integration, since this is an indefinite integration. Question number 3, part A. Determine whether this equation has two distinct real roots, two equal roots, or no real roots at all. So what I have to do is to tidy up first. I'm going to start with cross multiplication and then do a bunch of algebraic manipulation, which leads me to this quadratic equation. And once you get there, the strategy is to find the value of discriminant, which is b squared minus 4ac. That's the one which determines whether we got two real roots, two equal roots, or no real roots at all. So in this case, I got a negative value for that. A here is 7, B here is 9, and C here is 5. So after substitution, you get the negative value, and that means we have no real roots at all. In part B, I have to solve this equation. So whenever I come across this type of equation, I prefer to use a dummy variable, introduce a new variable basically into the equation. So I'm going to take all the cube roots of x to be y. As soon as you do that, this is the new equation I have to deal with. I can make this a quadratic equation. Now I have to make this look like a regular quadratic equation, so I'm just going to multiply everything by y. The y in the denominator disappears. This y becomes y squared. Over here we will have 4y, bring everything to one side, and you get y squared plus 4y minus 12. And then after that, what I did is I factorize it. This is a simple factorization. I'm looking for two numbers. Their product is -12 and their summation is 4. Those numbers are 6 and -2. And then these are my linear factors. You put each one of them equal to 0, and that means my first root is -6 and my second answer is 2. However, I'm not looking for y, I'm looking for x. So I have to change everything back to the word of x. Since I defined y to be cube root of x, again, I'm going to write cube root of x to be -6. I need to get rid of the cube root, which is the same as fractional index of 1 over 3, and that can be done by raising both sides to the power of 3. Once you do that, the radical sign disappears, and you get x to be -216. Over here, for the second root, you do the same thing, and you find x to be 8. Question number 4. I'm given a polynomial, which is a cubic, it's called px, and then in part A, I have to find the remainder when p of x is divided by x minus 2. So I can use remainder theorem. All I have to do is to put x minus 2 equal to 0. That gives me a value for x, and then substitute it into my polynomial instead of all the x's, and the final answer would be the remainder that I get when I divide this polynomial by x minus 2, and in this case you get 33. In part B, I have to show that 2x minus 1 is a factor of p of x. Well, over here I'm going to use factor theorem, which says if you find the root of your linear factor, in this case it is 1 over 2, and then substitute it in the polynomial, if it makes it equal to 0, that means the linear expression that we have is truly a factor of p of x. So you just make the substitution. Over here you get 1 over 8 with the 6 cancel out, and you end up with 3 over 4. Over here I get 1 over 4. Together these two become just 1. Over here I have -6 and 5, which adds up to 0. Therefore 2x minus 1 is a factor of p of x. In part 2, I have to write p of x as a product of linear factors. So this is the original cubic expression of p of x, and this is the linear factor was given to me. So that means there must be such a quadratic factor that when I multiply it by this linear factor, I get the original cubic expression. So there are a few ways you can answer this question. The most common one is to perform long division and get this quadratic. However, what I like to do is a method called by inspection or comparing coefficient. So let's just call the coefficients of your cubic expression a, b, and c, and then with simple comparison you can find the a, because you have to ask yourself, how can I get the 6x cubed on the left hand side when I multiply 2x by ax squared? That means 2ax cubed, therefore 2a has to be 6, that means a is 3. You do the same thing for c. How can I get a 5 on the left hand side when you multiply the constants on the right hand side together? So that means negative c is 5, therefore c has to be negative 5. And lastly, you need to find b. Finding the b is a little bit tricky. You got two options. You can either put your focus on the x squared term or the x term. So over here, I chose the x squared term. So on the left hand side, I just have 1x squared. On the right hand side, however, there are two ways I can obtain the x squared term. And that means when I multiply this guy by -1, that gives me one of the x squared terms. Another time when I multiply the bx by 2x, that also ends up with x squared term. And that's what I did here. Don't forget you already found the value of a in the first part. So here I get negative 3x squared plus 2bx. Therefore, just equate the coefficients and it leads to the value of b, which is 2. Now that I found my quadratic expression, I can go ahead and factorize it further because they want all the linear factors. So you can use any factorization technique that you learn. So you can also use the box method. This is quite an easy factorization. So I get 3x plus 5 times x minus 1, and that's the final answer. In the last part, I have to solve this trigonometric equation, which looks very complex. However, since the word hence is used, I have to get help from the previous part. And if you look closely, this is nothing but the polynomial that I dealt with from the beginning. However, all the x's are replaced with sine theta. And since I found the product of all the linear factors in the previous part, I can rewrite these as a product of three linear factors, which I did here. And if I want to find the answer, I have to put each one of them equal to 0. For the first one, sine theta would be half. Over here, sine theta would be -5/3. And lastly, I get sine theta equals to 1. However, you need to watch out for the domain. So you take the arc sine of both sides. This is quite a famous angle. Which angle its sine is half and it's bounded between 0 and 90, including 90. That is 30 degrees. For the second one, we do not have such a value for the theta. Lastly, sine of what angle is 1, and that is 90 degrees. So these are the two answers. Question number 5. I'm given the equation of a curve and I'm told that the tangent to the curve at the point where x equals to 1 cuts the x-axis at the point P. Find the equation of the tangent in the form of y equals to mx plus c, where m and c are exact values, and hence find the x coordinate of P. So since we're talking about tangent, the first thing I have to do is to take derivative of my curve. Now be careful, the first part of the curve is a composite function, so derivative of e to the power of x is obviously e to the x. However, since here the power is 2x minus 1, you need to multiply it by the derivative of the power, which is 2. Of course, there was a 5 initially there. Don't forget to put it there. And e is just a number, is a constant, and its derivative is 0. So the final answer would be 10e to the power of 2x minus 1. Now I'm told that the tangent is at point x equals to 1. So I'm just going to go ahead and replace all the x's with 1, which results in 10e, and that is nothing but the slope of my tangent line. Now, I want to find the equation of the tangent line. As you all know, if you want to find the equation of any straight line, if you have the slope already, you need an existing point on that line as well, where the x and y coordinate is known. So I already know the value of x, which is 1. However, I do not have the value of y, and you can find that easily by substituting 1 in the original equation of the curve, not the derivative that you took, in the original equation of the curve, and that leads to 5e plus e, which is 6e. Now I got the slope, I got the point. I'm just going to go ahead and make the substitution, and I can find the c or the y-intercept, and the final answer is y equals to 10ex minus 4e. This is the equation of the tangent line. The first part of the question is answered, but now I have to find the x coordinate of p. And since p lies on the x-axis, that means its y coordinate is 0. So I'm just going to go ahead and replace the y here with 0 and make x the subject of the equation. So bring this guy to the other side, you get 10ex equals to 4e. You can divide both sides by 10e, which results in x to be 2/5. And that's the x coordinate of point P. Question number 6, part A. I have to show that this expression can be written as this. So basically, it's the same as asking you to prove this identity. So I'm just going to start with this expression and work my way towards the right-hand side, or this expression. So I'm just going to start with replacing the cosecant and cotangent with their equivalent value. So cosecant is nothing but 1 over sine x, and cotangent is cosine x over sine x, where the sine x cancels out and you're left with 1 over cosine x. And since I need a tan x over here, and since tan is sine over cosine, so I'm just going to split this sine cube x into sine squared x times sine x. Therefore, this part can help me to obtain what I was looking for. And also, I'm left with the sine squared x that was initially in the question, and that's how you show it. In part B, I have to solve this equation for this domain. Now, since I have a tan x in both of my terms, I'm just going to factor it out. That's how I start solving it. And then I put each of those factors equal to 0 separately. If tan x equals to 0, that means x has to be 0. And for the second expression, if cosine squared x equals to half, you can take square root from both sides. So cosine x is plus minus 1 over square root of 2. And we have to look into each of these conditions separately. So that's why I wrote them here separately. If cosine x is 1 over square root of 2, this is a famous angle. So 45 degree, or pi over 4. Also in the fourth quadrant, the negative pi over 4, it has the same cosine, because my domain, after all, is from negative pi all the way to pi. So for the negative part, we get 135, or 3 pi over 4 over here. And also in the third quadrant, we get the same answer, but this time it would be negative 3 pi over 4. You have to be careful. You could say 5 pi over 4. However, that would be wrong, because the domain is specifically from negative pi all the way to pi. So you need to rewrite this as negative 3 pi over 4. Question number 7. I have to find the number of different ways the 9 letters of the word polymath can be arranged when the O and A are not next to each other. So what I'm going to do here is to calculate all the different ways that I can arrange these letters in polymath. That would be 9 factorial, and subtract those scenarios where O and A, they fall next to each other. So if this is the case, I can consider that just a big cell, O and A, and the rest of the 7 letters. Over here, O and A can be arranged in 2 factorial or 2 ways within this cell, and I have a total of 8 cells, which means they can be together 8 factorials times 2 factorial ways, and I'm just going to subtract it from the total, which leads to the number of ways that they're not next to each other. And in part, I have to find the number of ways that the letters math are together in this order. So I have 5 letters here and 4 remaining letters. So I consider this just a big cell. With these 4 cells, I have 5 cells. And in how many ways 5 cells or 5 units can be arranged among themselves? That would be 5 factorial, which is 120. Question number 8. An experiment was carried out and values of y for certain values of x were recorded, as you can see in the table. The relationship between y and x is modeled by y equals to a e to the power of kx, where a and k are constant. You're supposed to draw a straight line graph for ln y against x. Since the graph I'm supposed to draw is ln y versus x, so that means I need to go ahead and find the values of ln y. So I've added another row to my table just specifically for ln y. You can just use your calculator, take the ln of each of these values, and you get the corresponding values of ln y. And in the place provided here, mark those points. And over here I have 5 points, and just connect them. Make sure you draw the best fit line, and this is what I get. In part 2, I have to basically use the line that I just drew in part A and find the equation of the line. That means A and K has to be found. So if you look at the straight line that I just drew in part A, my y-intercept is 1.8. That's right there. This is the y-intercept. And I need to find the slope as well. All you have to do is just choose 2 points over here. I chose the 2 ends, the rise over run, and if you do that, the value you get is nothing but 0.03. Here's the calculation for that. And also, as I just showed you, the y-intercept is 1.8, therefore this is the equation of the line. However, a and k needs to be found. So if you look at the original equation of the curve, if you take ln from both sides, then over here I can use the law of logarithm, known as the law of multiplication. So I can split this up, and also ln e to the power of anything is basically the power. That's why you can see the kx over here. And the rest is just a matter of simple comparison. If you look at x here, the coefficient of 0.03, therefore k has to be 0.03. And if you look at the constant here, it's 1.8. Therefore, ln a has to be that. I can use e again to find the value of the a exactly by forming this equation, and that leads to a to be 6. In part C, I have to find the value of x when y is 17. Now that I obtained the equation of the line in previous part, I just have to substitute y with 17 and attempt to find x. So over here, I have to make x the subject of the equation, and that is nothing but ln 17 minus ln 6 divided by 0.03. You can use your calculator, and the answer would be 34.7. Question number 9. I'm given the graph of a curve, and that is a parabola, as you can see, and also there is a line AB which cuts this parabola at point B and point A, and there is also a line CD which is parallel to y-axis, and also if you extend it, it's gonna pass through the maximum point of this parabola, and I'm supposed to find the area of the shaded region. Well, if you refer to the formula, the area of a shaded region trapped between two curves can be found using integration, where the f of x is the top one and g of x is the bottom one, and where the limits of integrations are respectively a and b in this formula, which lies on the x-axis. So that means first I need to know the coordinates of A. To be more specific, it's x-coordinate because the y-coordinate is obvious, it lies on the x-axis. Now that can be done by simply taking the equation of the parabola and replace the y with 0. Once you do that, you get this quadratic equation. For simplicity, I divided everything by -4, and I got x squared minus 8x plus 12 equals to 0. I used factorization. Two numbers, their product is 12, and their summation is -8. Those are -2 and -6. If you put those linear factors equal to 0 separately, you get the roots to be 2 and 6 respectively. Over here, the x-coordinate of A would be the smaller one, and that kind of makes sense because if you extend the parabola, the bigger x would be right here, and that would be 6, so this has to be 4. Now that I found A, I have to find the equation of the line AB, because later on I'm going to use it in this formula. So that can be found easily by finding the slope of the line. So 2 points on the line are known, A and B. You can use the famous formula of y2 minus y1 over x2 minus x1, and that would be the slope. You make the substitution, you get m to be 4, and also I need a point that lies on that line. I took the line A in this case and just plug it into this formula to get the equation of the line AB. So the equation of the line AB is 4x minus 8. Now I need to find the maximum point of the parabola because the x-coordinate of point C is going to be the same as the x-coordinate of the parabola, and that would be the upper limit of my integration in the end. So over here, what you can do, you can either use the formula which says the x-coordinate of the maximum or minimum point of any parabola can be found by dividing -b over 2a, where b is the coefficient of the x term and a is the coefficient of the leading term, or the x squared. Or you can use the fact that this parabola is symmetrical. That means if the x-coordinate of a is 2 and over here the x-coordinate is 6, right in the middle, that would be the x-coordinate of the maximum point, which is the average of these two, and that would be 4. There are a few ways actually which can help you to find the x-coordinate of the maximum point. Now that the x-coordinate of the maximum point is found, so the limits of my integration is found, which are 2 and 4 respectively. This is the equation of the parabola. This is the equation of the line AB that I found. Don't forget, you need to subtract the top minus the bottom one, and then the rest is just a matter of integration. You can tidy up by combining the like terms first. I get this quadratic. For the integration, you need to add 1 to the power and divide by the new power, and I would get this expression. Obviously, for the constant, there would be an x after the constant. Now it's time to apply the limits of integration. One time I put 4 instead of all the x's, minus another time I put 2 instead of all the x's. You can simplify this or just key in everything in the calculator, and the final answer would be 13.3. Question number 10. The functions f and f of g are defined by these two expressions, as you can see, where the domain is stated right here. In part A, you're asked to explain why the inverse of f exists. So this is quite a straightforward and easy question. Remember that there were 4 relations, out of which 2 of them were functions, and out of 2 functions, only one of them had an inverse. So those 4 relations are 1 to 1, 1 to many, many to 1, and many to many. And out of those 2, 1 to 1 and many to 1 are considered to be functions. And one of those 2 functions can have an inverse, and that's only the 1 to 1 function. And as you can see, f of x is an exponential function, which gonna look something like that. And that is definitely a 1 to 1 function because it simply passes the horizontal test, which means for every unique x value, we get a unique value for y. All right. So in part B, I have to find expression for the inverse function of f and state the domain and range of that function. Well, this can be done simply by writing f of x in the word of x and y. Instead of f of x, I write y and then swap x and y and then try to make y the subject of the equation. That means I need to bring this y down somehow. That can be done by taking ln from two sides, because this guy over here disappears and I'm left with just y squared plus 2. That's one of the properties of logarithmic function. And then I have to bring the 3 to the other sides, become negative. And lastly, I have to take square root from both sides, which leads to y equals to plus minus the square root of ln x minus 3. However, I ignored the plus sign, because if you look at the original curve itself, the domain, which is represented by the x, has to be negative or less than 0. And don't forget, in the inverse function, all the x's becomes the y's. In other words, the domains are now the range in my inverse function. Therefore, y here has to be less than 0, which explains why I rejected the positive value. Now, if you want to find the domain of this function, you need to consider the expression under the radical. There is a limitation for us. For anything that is under the radical, it has to be greater than or equal to 0. That means ln x minus 3 has to be greater than or equal to 0, which means ln x is greater than or equal to 0. Now I can just use the base e to bring the x down. Therefore, x is greater than or equal to e to the power of 3. And that's the new domain. And the range, as I stated before, it has to be less than 0. In part C, I have to find and simplify an expression for g of x. Don't forget the word hence is used here. So that means I have to somehow use what I have obtained in the previous part. So in the question itself, I'm provided with the composite function of f and g, that is e to the power of 2x. Now, if I want to find g of x, since the input here is g of x and the output is e to the power of 2x, I can just take inverse function of f from both sides. That means the output of this composite function is now the input of the inverse function. So of course it's expected to get g of x as an output. I have already found the inverse function of f, which is negative square root of ln x minus 3, but now I need to replace all the x's with e to the power of 2x, and that's what I did here. Also, ln e to the power of 2x, it simplifies down to 2x, and that's the final answer. Question number 11. In the binomial expansion of 2 plus x over 2 raised to the power of n, the first three terms in increasing powers of x are these terms, as you can see here. I have to find the values of the constants n, a, and b. So let's go ahead and apply binomial theorem to find only the first three terms. So as you know, the binomial theorem starts with NCR, where the r starts from 0, and we have an increment of 1 each time it is increased by 1. And the first term is raised to the power of n, while the second term we start with 0. And as we go on, we decrease the first power by 1, and we keep increasing the second one by 1. And this is what I get. So now it's just a matter of tidying up. Anything to the power of 0 is 1. Also, c and 0 is 1. Therefore, my first term is 2 to the power of n. For the second one, nc1 is n. And over here, the 2 to the power of n minus 1 divided by 2 can be simplified further, which I did in the third row. That's 2 to the power of n minus 2. And over here, nc2 can be written as n times n minus 1 divided by 2. If you recall, this is the formula for combination. You can just plug in and find out the final answer. And over here we have x squared divided by 2 to the power of 2, which I can later combine these two together to get 2 to the power of n minus 5. And now that I found my first three terms, I have to make a comparison with the expression that I'm provided with. I'm going to start with the first constant, which is b, because then I can use it in the second and third expression to find the unknown values. So by simply comparing this to this, you can see that b has to be 2 to the power of n, and that's what I found here. Then later compare the coefficient of x here and the coefficient of x in the expression provided to us. Therefore, AB has to be 2 to the power of n minus 2 times n. Given that b is already 2 to the power of n, I can replace it with 2 to the power of n, which cancels out with this 2 to the power of n, and I'm left with a to be n over 4. Now in the third row, I'm going to replace a and b, which I found earlier, and multiply it by 9 over 8, and that has to be equal to the coefficient of x squared right here, and that's what you obtain. This is just a matter of simplification. You can start by replacing a and b first, and then what I did over here, I actually brought this 2 to the power of n minus 5 down to combine it with this 2 to the power of n minus 2. After you do that, you basically get 2 to the power of positive 3, which is 8, and then 8 and 8 over here cancels out, and you left with 9n. And then after that, you expand this bracket, bring this 9n to the other side. That leads to this quadratic equation. You could have canceled the n, however, over here and obtain a n to be 10. It wouldn't affect the final answer because after all, n equals to 0 is not the answer to this question. It doesn't make sense. That's why over here, the root which has the answer 0 is rejected, and I only accepted the other answer, which is 10. And now that the n is found, I can go ahead and find the value of my a, because a was defined in terms of n, as well as b, which was 2 to the power of n. So over here, you make the substitution. You get a to be 5 over 2 and b to be 2 to the power of 10, which is 1024. Having said that, we can put an end to this paper because this was the last question. I hope you enjoyed the video, and please leave in the comment if you have any doubts or question. I'll be more than happy to answer, and I'm gonna see you guys later with a full solution to another paper. Thank you.